All right, let's go on to part 2 of interdependence. All right, so now we're going to talk about ecological pyramids, which is another way to illustrate what's going on in like an ecosystem. So what this does though that's different than the food web is it shows amounts. So the size of like the chunk of the pyramid indicates like an amount of organisms. So it shows the relative, meaning comparative, amounts of energy or matter within each trophic level. So if we go back to this food web, it doesn't show us how many heron there are, or how many hawks there are, or how many sandhoppers there are. So the size of these pyramid chunks represent the number of organisms. And typically, except for sort of some unique situations, we're going to always have to have more producers at the bottom to provide for a certain number of herbivores, which will provide for even less carnivores. So if there's way too many carnivores, they're going to eat all the herbivores, and this would shrink down. But eventually it should go back to like a pyramid shape as long as everything's healthy and functional. So like if the mice overpopulate, they may eat too much of the grass, which would shrink this down, and then eventually they're going to run out of food and they're going to starve, and they would shrink back down. And it would maybe, just readjust, but hopefully go back to a pyramid. There are some that might make like a popsicle shape, which I'll talk about, but normally we're going to expect them to be like a pyramid. So this is the main one that you have to know, which is called the energy pyramid. And this shows the percentage of energy that is transferred between each trophic level. So I'm going to maybe keep things a little vague on this one for the online activity. So I'm going to not say everything. I'm going to want you guys to kind of figure it out. But it's really pretty obvious if you analyze the picture. So I'm going to try to not tell you everything and see what we got. So what we can see here is 100% of the energy is made at the producer level. And then you can see a huge amount is lost as we move to the next level. So, and that's going to be one of the questions, is how much energy is lost. All right, and then as we move to the next level, we see actually the same equivalent amount of energy is lost. And then it keeps moving up. So if somebody really wants to have direct access to more energy in their diet, they should eat the producers, which makes sense because if we go back to Unit 1, we studied carbohydrates, and carbohydrates are our primary energy molecule, and carbohydrates are created by the producer. So it makes sense that they have 100% of the chemical energy that's provided. And so if you ate like a chicken, which would be at this level, you're only getting 10% of that energy. Or if you ate an animal that ate the chicken, like we ate a carnivore or something, we're really getting very little of that energy, and that's why they provide mostly just like protein as opposed to carbohydrates. And so here we see some stuff coming out of the pyramid, so let me point that out. And we also see some stuff coming into the pyramid. So for the questions that I'm going to eventually ask, you want to use the data that is within this image to figure that out. This is a different one, and it shows some of those arrows leaving, like we see here, the leaving arrows. And I usually in class try to have somebody figure out what's wrong with this, and I'm always actually really glad when somebody figures it out. What's wrong with it is actually there's fungus down here, and fungus are decomposers. So this level actually in this picture represents producers, which decomposers are not. They do not produce energy. It's cool that they put the mushrooms to make it seem like they're important, but it's inaccurate. So then we move up to the herbivores, and to the first level carnivores, and then to the higher level or apex carnivores. So, all right. I'm going to jump through that really quick because that's going to be what I skipped on the screen there is going to be in the questions. So I guess if you pause it, you'll be able to see them, but try to figure it out on your own. It's actually pretty easy. All right, the next type of pyramid is a biomass pyramid. So mass means like an amount of material. So like you could have a bowling ball that's the same size of a balloon, but the bowling ball is way more massive because it's just got way more material and atoms in it. So this shows the amount of living material at each trophic level. So this one's pretty much always going to have to be a pyramid, just like this one does, where you're going to have more producers providing for less herbivores, providing for less carnivores. So then So with the biomass, this one has got to always be a pyramid. You always have to have more producer material to provide for the next level of herbivore material for the next level up. If we do something like we cut down a bunch of crops or we cut down a forest and we reduce the amount of biomass in the forest at the producer level, the animals above will starve and die and things like that. And this is why going in and destroying forests, this is corn here, but if this was a forest, if we cut the forest down in half, all the animal life also has to reduce down with it into a skinnier pyramid. And this is why destroying forests or ecosystems is problematic for the organisms and animals that are surviving off those really important producers here at the bottom. And this one's more about like a farm kind of pyramid though, because we've got a human at the top. All right, and then the numbers pyramid, this one can kind of break the rules a little bit and make like a popsicle shape, maybe. And this shows the total number of species. So this would be like straight up counting. So obviously if we were going to count these things, there has to be more blades of grass than there are rabbits. Because if there's 100 blades of grass and 100 rabbits, that's not enough food for the rabbits. So they're going to starve, shrink down, and then there'd be more grass than rabbits again. There's got to be more rabbits than there are rattlesnakes, or there just won't be enough food to go around. And there's got to be enough more snakes than hawks, or there won't be enough food to go around. So when we're talking about grass, there absolutely has to be a bigger amount on the bottom, like we have on both of these. But, and I usually bring this up in class, this can make kind of a popsicle shape. So kind of think about it for a second. I want you to think, how might there be, if we counted them, not that many plants on the bottom, but still able to provide for numerous animals on top. So maybe even one plant providing for many animals. And I'm sure some of you are already getting where I'm going at. That would not work for grass. There's got to be more grass than rabbits in order to provide for the rabbits. But there are certain types of plants that can maybe help break that rule. So maybe you're already figuring it out. I'm going to move on. So that would be like a big tree. So let's say we have one tree, like let's even say like the biggest trees ever, as far as we know, which are the sequoia redwood trees, which are like buildings almost, they're so big. Let's say we had one giant sequoia, just one, so counting the number, it would be one, and that would be really skinny on the bottom, because there's just one of them, but that could provide food for maybe thousands of insects, for instance. So this would be really big once we get into these higher levels. And then there could be animals in the trees that are eating insects, and then eventually there's birds that eat, hawks eat those carnivores that are eating the insects. So we could make it more like a popsicle, where it's really skinny on the bottom, like one tree, and then starts getting wide again, thousands of insects living off the tree, hundreds of lizards and bigger insects eating them, and then eventually higher level predators on top. So it would be kind of like a triangle popsicle on a popsicle stick. And so typically, except for the numbers pyramid, which can be a little different, all three pyramids need more organisms in the lower levels to stay in balance and for the ecosystems to remain healthy. And this is another reason. And if we see, they're all relying on the producers or the plants or algae. None of these are ocean or water, but we could put an ocean or water one and have it be algae on the bottom, in which case there's going to be a lot because algae is really small, typically. So yeah, this is another reason why we need to protect our producers, our plants and algae, so they can provide energy, biomass, and just have enough food for the levels of animals that work their way up in the ecological pyramid. All right, that's it for part 2.